So I think it's safe to say that the past month or so has not been the best time for Anthropic. We just had the Claude Code leak that happened, then even a few weeks ago, which is what I want to cover in this video, Claude Code actually mass committed 501 times to try to build a C compiler from scratch. And you may have heard, but none of it actually compiles. Now I'm going to put a bunch of stuff on screen so you guys can see what I'm talking about here, but Anthropic put 16 Claude agents on the task of building a full C compiler in Rust. They did 501 commits, created thousands of files, they were targeting 4 different CPU architectures, and Claude announced this, and on paper it sounded pretty incredible. But then the community actually tried to use it, and it couldn't even compile Hello World. So it was almost 500 people that reacted to that exact issue on GitHub, which I'm going to show on screen here. But here's the thing. Somebody actually went out and fixed every single problem with this C compiler and then built an even better compiler completely from scratch using AI, just with a different methodology, which I'm going to get into here in just one second. All right, so let me set the stage here and kind of explain what happened. Now, about a month ago, Anthropic published a blog post about a project that they called CCC, or the Claude's C compiler. Now, the idea here was pretty ambitious. They were going to take 16 Claude agents, have them work together under the guidance of a senior researcher who's kind of prompting the models, going back and forth with them, and then build a full C compiler in Rust that's targeting different architectures like x86, RISC-V64, i686, etc. Okay? Now, this is a pretty serious scope. This is a large project and something I couldn't code up from scratch. I'm sure many of you couldn't do. The idea was that the agents should be able to communicate with each other and build this. And to be honest here, I gotta give a little bit of credit to Anthropic. This was a genuinely impressive experiment, and the fact that the AI agents could even attempt something like this is a pretty meaningful step forward for agentic coding. If you told me a year ago that this was even remotely possible with AI agents, I probably wouldn't have even believed you. And the thing is, a C compiler is one of the hardest pieces of software that you can build, so the ambition here was definitely real. But obviously, when the community started digging into this, they found a bunch of problems. Now, the whole project actually relied heavily on one human expert. Now, this was a senior researcher who logged over 2,000 interactive turns, writing test cases, resolving merge conflicts, debugging, communicating with the agents, and the agents couldn't really self-correct or validate their own output at scale. So they were producing a bunch of code, but it didn't really lead to the result that we were looking for. And here are some of the issues that a bunch of the community found in this C compiler. The ARM assembler had instruction encoding bugs, the x86 assembler had broken conditional processing, there were cross-architecture alignment bugs, there was entire chunks of the C11 that were missing, and there was no real optimization pipeline, and there was no meaningful test infrastructure as well. Now, all of those are definitely problems, but the one major thing that caught a lot of people's attention is that not a single commit of this entire GitHub repository actually produced a working build. Meaning if you went, you pulled it down, you tried to run it, you could never get something functional. Now, I'm not just saying all of this to dunk on Anthropic. What they showed is that AI agents can take on massive, complex engineering challenges, and this is pretty cool that they could even get something remotely close to working. However, it did reveal something important. Without a human expert who's acting as the architect, the context engineer, the QA, right? Basically project managing the entire build, these agents can't get to the finish line on their own, and they produced scaffolding, not production or enterprise software. Without that person sitting there coordinating the agents, they can't really do anything meaningful. Now, this is where the story starts to get really interesting, and I'm going to share something with you that you probably haven't heard about the CCC or Claude Code compiler. Now, there's a company called Blitzy. I partnered with them a lot on this channel, and they saw that Claude's C compiler was broken and said, hey, we can fix every single one of these issues. And they went even a step further and they said, actually, let's try to build our own C compiler completely from scratch to compare our AI model or scaffolding, orchestration, whatever they have, which we'll talk about in a second, to Claude Codes. Now, Blitzy isn't just an LLM or another vibe coding tool, and in fact, it's not actually even trying to compete with Anthropic. What it is a fully autonomous AI software development platform. Now, the way that it works is fundamentally different from what Anthropic did, and that's why it kind of makes it interesting here. Now, Blitzy starts by building a deep understanding of your codebase. So it actually maps the entire codebase and constructs a dynamic knowledge graph of the entire system. So dependencies, architecture, various patterns, conventions, whatever, right? Now, they call this the infinite code context because it can handle code bases with over 100 million lines of code. Now, it doesn't do this in 5 minutes. When I've used Blitzy in the past, it can take hours, it can take even days, depending on how complex and how large the code base is. And it will generate a massive document that's usually hundreds of pages long, and I've shown this in many videos before, that maps everything out so that when the AI does start making changes or producing code, it actually knows what it should be doing, and it can follow this code base and all of the conventions and patterns that already exist. Now, once Blitzy understands the code base, it starts orchestrating thousands of specialized AI agents that plan, build, and validate your code completely in parallel. Now, we're talking about agents that, again, run for hours or days. In my cases, I've had tasks as short as 5 hours, as long as 3 or 4 days. And what these agents do is collaborate across the entire code base. Now, the platform here can actually batch build up to 50,000 lines of code in a single run without you having to interfere or ask the agent anything else. And there's actually multiple QA agents that are checking each other's work consistently before any code gets delivered. So there's a built-in review loop, and it's not just raw generation, and that's kind of what makes this unique, is the orchestration of literally thousands of different agents. Now, this covers the full development lifecycle, so everywhere from requirements, design, code, test, PR, etc. And they recently scored a 66.5% on SweetBench Pro, which is independently audited, and at least to my knowledge, one of the highest scores, if not the highest scores, for any AI platform, tool, LLM, whatever you want to call it. So all of that is to say that effectively Blitzy works a lot differently than something like Claude Code or Codex or these other tools, even like cursor models, whatever that you're using, where those really rely on you sitting there in the terminal, orchestrating the agents, sending a lot of different messages, opening up different sessions, pressing approve, reject, whatever, right? You guys know the process on what AI coding typically looks like. With Blitzy, you literally submit the entire code base, it understands it, you then give really detailed long prompts. I've shown this in some other videos. It then goes, orchestrates the agents as I explained, spends multiple days in some cases building the code using those different agents, and then delivers you the result. So with all that said, what Blitzy decided to do is say, hey, okay, Claude Code wasn't able to do this effectively. Let's see if we can first of all fix any of the issues that they had using our approach, and then can we build it from scratch? And that's what I want to get into right now. So what Blitzy did here is ingest the CCC repo that had all of those different issues, right? It built out that knowledge graph of the existing architecture, so whatever Claude Code had built itself, and then they fixed all 13 critical PO regressions. They fixed the ARM assembly encoding issue, the x86 conditionals. They fixed all of the major problems that you saw in the original build and that people were pointing out on GitHub. And then on top of that, they built a real tiered optimization pipeline. They had loop unrolling, tail call optimization, etc. And for the test suite, they had 753 of 753 unit tests passing, all of the integration tests passing with 0 issues, and everything actually compiling and working properly. I'll put the repo on screen, you guys can check it out if you want, I'll leave it in the description as well, but that's just the start. So like I mentioned before, Blitzy didn't just stop at actually fixing the issues in the current repository. What it did is attempted to build its own compiler completely from scratch. Because it's one thing to fix existing software, all of the scaffolding architecture, majority of the code is there, and it's just fixing the bugs, but it's another thing to actually build it from the ground up without relying on any pre-existing code. So what they were actually able to do here using the agent platform I talked about is rebuild everything completely from scratch with 2 prompts. I'm going to get into what those are in a minute, but that is just insane compared to the 2,000 that was used by the expert that was working with the Claude Code. So for this project, they named it the Blitzy C compiler, or BCC. They generated 229,983 lines of Rust. They had 129 source files, 2,271 tests that were all passing with 0 failures, and they had 0 warnings, 0 formatting diffs, 0 external Rust dependencies, and same thing as before, they targeted 4 architectures, so they did the exact same as Claude's, x86, i686, AArch64, and RISC-V64, RISC-V 64. And here again is the most important thing, right? Claude's compiler needed the senior researcher who logged 2,000 interactive turns over 2 weeks. Whereas with Blitzy, they coordinated 3,600 agents autonomously just through the platform. They had a total engineering time of 624 hours of parallel agent work, and that was compressed into about 4.5 days of execution. Then with the human, it was just 2 turns, so literally 2. They had 1 to submit the prompt and then 1 to refine the final PR so that it would work for Linux validation. So effectively on the first run, almost everything was fully functioning. They added 1 more prompt and then everything was good to go, and that's what you're looking at right now. Now look, I'm not going to get into all of the technicals here. You can read it from the blog post, which I'll link below, but effectively the proof that this worked is that the Blitzy C compiler, first of all, compiles, and it runs SQLite, Redis, Lua, QuickJS, Zlib, and the big one, it actually compiles the Linux kernel and boots successfully. And if we go through all of the details here, the Blitzy C compiler leads in 15 of the 22 measurable categories when comparing the two different AI-generated software, right? And this is backed by all of the committed test results, which you can go and see for yourself. So all of this is cool, but I want to zoom out here and talk about why this actually matters. Now look, this isn't about compilers, right? No one really cares that much about C compilers and if AI can generate them, but what's happening here is we're seeing really the frontier of AI-generated software. We've seen that certain approaches just don't work that effectively. When Anthropic's team, or in this case the expert researcher, was just using Claude, right, the Anthropic models or Claude Code, it required 2,000 interactions. It got something very cool and very close to working, but still with all of the issues that you saw. And then with something like Blitzy, this is kind of showing where we're moving to in terms of agentic software development, where rather than having these short sessions where you're going and chatting with the model and going back and forth 2,000 times, by having the right orchestration framework, and in this case, 3,600 individual agents, it can actually build full-scale enterprise software with the context engineering and, again, the multiple days of work. Normally, when we're writing code or we're doing the AI gen, it's back and forth very quickly, 2, 3, 4, 5 minutes of generation. In this case, you spend more time on the context up front, more time on the prompt, specifying exactly what it is that you want, and then the AI agents can go out, and in this case, work for 624 hours, which is like multiple days, right, in parallel, and generate fully functioning enterprise software, which is kind of crazy to think about that we're already at that stage and we're just at the beginning here of 2026. Now, of course, everything that I mentioned in this video, I'll leave in the description so you can check it out, read it for yourself. Obviously, you don't need to take my word for it, but I want to let you know quickly of a really cool opportunity because on my channel recently, I've been talking a lot about OpenClaw, AI agents, AI orchestration platforms. And if you're someone who's interested in that, you've been building OpenClaw bots, then I want to let you know about a really cool opportunity that Blitzy actually brought to my attention. Now, this is called ClawComp, and it's a program where teams of 2 to 3 people can apply to each get a free Mac Mini shipped to them to build a workflow or a product using OpenClaw. Now, the competition culminates in a week-long hackathon where you'd get flown out to Link Ventures. This is a venture fund in Boston, Massachusetts. All of the travel, housing, all of that stuff will be covered by Link Ventures for you. And honestly, it's a great way to get hands-on experience with the kind of agentic technology that we've been talking about in this video and a lot on this channel. Now, if you're interested in that, again, it's called ClawComp. I'm going to put the link in the description. Really cool competition. Definitely give it a shot. And I mean, if you get a free Mac Mini, that's pretty cool alone. If you get flown out there, I mean, that's going to be a great opportunity, something to build the resume, etc., and probably just a lot of fun. So look, to recap all of it and close it out here, Claude built a C compiler that couldn't compile Hello World. Blitzy fixed all of the issues and then built an even better one from scratch with 230,000 lines of Rust code, pretty much zero human code, very little human intervention, just the few prompts that I talked about. It was able to boot the Linux kernel. Now, this is the future of software development that we are seeing right now. It is crazy what AI agents are capable of, but it is very clear that the way in which we orchestrate them is really what the future is going to be about here. We have really good base LLMs, but they need to be used in the correct environment. And if they have the right harness around them, what they're capable of building is really mind-boggling. And I don't know what I'm going to be talking about in 2 months from now as things get crazier and crazier. Anyways, let me know what you guys think in the comments down below, and I look forward to seeing you in another video.